Hello guys, today I want to talk about an aspect of Ethereum that we haven't really focused on at all yet, but it's very important. It's something that you'll come across very early on when you start exploring within Ethereum and reading documentation. Again, like a lot of things, it's not immediately intuitive, and that topic is the whole sort of money side of things. So, but both the link between Ether, the currency, and also and the link between that and WEI, WEI, and then also heavily linked to that the concept of gas limit, gas price, what they mean, and how all those concepts tie together. So this is going to be I'm going to sort of take you through some examples step by step to show you how all of these themes I've just mentioned tie together. Yeah, let's get going. All right, so the first thing, which is probably the easiest to explain, is the underlying cryptocurrency itself, Ether. And if you have a quick look on Google, it's very straightforward to see the current market price of one ETH or one Ether, right, which is currently just over $39, right? And this Ether, just like Bitcoin and other cryptocurrencies, are traded on the open market. They have an exchange value which is determined by supply and demand into and out of all of the major currencies, right? So Ethereum, the digital currency, the cryptocurrency, is really the lifeblood of the whole Ethereum ecosystem, or the whole Ethereum network. And as I mentioned in previous videos, the main difference between Ethereum, which transfers Ether from participant to participant, the difference between that and Bitcoin, which obviously transfers Bitcoin, is that Ethereum allows a lot more functionality to be implemented on the blockchain at the same time. And hopefully I've shown you a few examples in previous videos of very basic smart contracts which essentially give Ethereum a whole added dimension other than, let's say, over and above simple transfer of cryptocurrency and enabling payments in that cryptocurrency. But it does do that. The currency is Ether, and the current market price is just over $39, and that's as of the 18th of March, right, 2017. Okay, that one's fairly easy, right? So the next one in the list here is WEI, right? Now, what the hell is this? Is it another cryptocurrency? No, it's actually, this is probably even simpler to explain than the first one. This is just a breakdown of Ether, so a much smaller unit of Ether. So in terms of, so if you think about dollars and cents, you know, a cent is just a 1/100th of a dollar, and in the same way, one WEI is a much smaller fraction of an Ether, and it's actually to the extent that 10 to the power 18 WEI equals 1 Ether, right? So, and the reason we have this WEI thing is because a lot of the applications of this currency when it comes to transactions, and we'll get to gas, essentially when it comes to gas, the individual units and the way that this stuff is consumed, this Ether is consumed, is so granular, so small that we really need to measure it in a much smaller unit. Okay, so that's WEI. So before we go on to talk about gas, I just want to quickly show you a quick example, just to hammer home the point about WEI. So when you in your Geth console, the balances you see are actually in WEI, right? They're not in Ether. So if I've got on my local node here, which I'm running, and just running per the previous videos, exactly the same setup, same commands, same network. I have so I've got 6 accounts registered on this particular node, and so if I look at the account, right, ETH.get balance of the last one, I see that there's no balance in there, right? So if I look at the first account, there's a very high balance in there, right? In terms of WEI, right? And that's because all the mining that I've been doing on this node. So this has been running obviously quite a long time now. We've got 24,000 blocks, and there's no mining. If I just restart the miner as well, right? and then so that balance is only going to carry on increasing now because my default mining account is my accounts 0. It's the first account on the node, which happens to be this one. Okay, so that's a very large balance, and that balance is in Wei, right? Now what I can do is I can convert that balance to a balance in Ether, right? So I can do web3.from Wei and then eth.get balance and then eth.accounts 0, right? So I can convert that effectively into Ether, right? So you can see this is the amount in Wei, and this is the amount in Ether, right? So that's the you see, you might be, why is it not exactly 10 to the 18 more? It's because we've started mining now, so the balance has gone up slightly. So 85,002 Ether, which at $39 per Ether would make me pretty financially happy right now. But obviously, because it's a private test node, I'm not participating in the main public blockchain. This is just and that's why it's great to run your own private thing, because you can play around with arbitrarily large balances and all that kind of stuff, right? So that's a very quick example of showing you the balance on accounts are in Wei in the Geth console, and you can convert them to Ether by calling this from Wei, right? So that's that. So the next one I want to briefly touch on is gas. Okay, so what is gas? Well, so gas is a measure of the cost in computing terms, not in Ether terms, not in monetary terms, but in terms of computer terms, of carrying out the operations that you're asking to be performed on the Ethereum blockchain. And those operations, those could be just sending a transaction, right? Any transaction. It could be you could be running code in a smart contract that adds numbers together, right? Or performs a SHA-2 hash on something. But anything that because remember, everything that you deploy in a smart contract to the blockchain, including functions that you're asking to run, anything that you ask the Ethereum blockchain to run, and what we mean by the Ethereum blockchain is that the miners who are looking at these transactions, coming over and trying to mine them into a block, and then as soon as they find the block, then they say, right, all the other nodes in the network, now you have to execute all of these transactions in the block. Only the miner gets the credit for it, as in gets the money for it, but you're incurring a computing cost on every single other node in the network that's validating that block, and which includes running those transactions in the block. This is something that I was always a bit confused about in terms of who gets the credit for the gas. It's only the miner who successfully includes that transaction, but the validators all incur the cost or all incur the computing penalty of having to execute the code that's in those transactions. So basically, think of gas as think of it just literally like we don't call petrol gas over in the UK, but I guess this comes from the US, where gas is what you use in a vehicle to achieve effectively getting that vehicle from point A to point B. And that might be involve going up a hill. It might involve going over bumpy roads. It might involve going over a long distance. But effectively, it's a measure. It's a fuel, and it's a measure of the cost in resource terms, not monetary terms, but resource terms of achieving that particular goal, right? Either in computing terms, executing a contract, or in vehicle terms, getting from A to B, right? So gas is a measure of the computing power required to do certain things. It's not a measure of how much it costs to actually have it executed, and we'll come to that in a second, right? So if we just have a quick look at some examples here from the documentation. So we can see down here, this is from I'll link this below, we can see some sample operations. So when we write our when we write our smart contracts in, and you saw in previous video in the browser where we had our greeter contract or adder contract, all that stuff that we write gets compiled down into basic operations, and those operations are allocated a cost per operation, right? So if I have an adder contract that's trying to add two numbers together, right? I think it mentions it up here. So the EVM opcode add, that consumes 3 units of gas, right? And so it's defined at the Ethereum protocol level that any contract, any code that you're trying to run is going to consume 3 gas, right? That's how it's defined. And you can see some other operations down here, like for example, completing a SHA-3 operation on a string. And here's an interesting one, which is basically the amount of gas that it costs to actually just send a transaction. So that consumes 500 gas, whereas adding two numbers together consumes 3 gas, right? So think of gas as just a representation of the computing resource required to execute certain operations, and it's defined by the Ethereum protocol itself. It's not like that it's down to the computer to assess how much CPU power it actually ended up doing executing the contract. The gas is defined by the Ethereum protocol. So I'm actually referring a lot to the documentation down here, and I'll link it below. And if you haven't come across this, then you'll probably find that reading it is as effective as watching this video. But either way, as long as you understand it, then that's great. The gas price, okay, the gas price is what you, as the initiator of a transaction, state that you're prepared to pay the successful miner, right, who chooses to and successfully mines that transaction in a block. It's what you state you're prepared to pay per unit of gas, right? And it's expressed in Wei. So this is the bridge between the gas, which is the computing resource that has nothing to do with monetary value or market forces or anything, and it's the bridge between that and the actual money that you are effectively paying the miner of the Ethereum block, which contains your transaction, that you're prepared to pay them for the to actually execute that, for taking that hit, for taking up those CPU cycles and the memory utilization, etc., etc. So gas price, and as it says down here, right? So this particular version of the Ethereum client had a default. So if you don't specify it in your transactions, because the gas price is something you can, it's a transaction parameter. When you, it had a gas price of 0.05 times 10 to the 12 Wei, right? So that was the default if you don't specify it. Now the important point is that by specifying the gas price in the transaction that you're prepared to use, it's kind of like an auction. You're saying to the miner, hey, please include my transaction and run my code in the block, because even that, yes, the code that I'm asking you to run is going to incur, let's say 30 gas, because it might be 10 times 3, 10 addition operations, which is going to cost the miner CPU cycles, etc., etc. But I'm prepared to offer you a gas price which is, let's say, 0.07 times 10 to the 12 Wei per gas, whereas other people might be offering less. So it's all about, so you're kind of bidding against other people who are sending transactions to the network to get your transaction in there first. You might be saying, well, why don't the miners just include all the transactions in the block? What's the incentive? And we'll come to that later on in the video. But just to give you a hint, it's because there's a maximum amount of gas that is allowed per block, right? So the miners have to pick and choose carefully which transactions they include in the block, because just like in Bitcoin, there's a maximum block size in terms of kilobytes, which means that they have to look at the transaction fees and prioritize the transactions that they're going to put in, rather than just saying, okay, all the transactions are welcome, we're just doing a hash anyway, so it's all random anyway. But so I hope that makes sense. So it's kind of like a bid. So the higher the gas price you specify, the more likely your transaction is to be included, because the miner will see it as a preferential return on investment in terms of their computing resources. but also obviously the more that you're going to have to pay for the transaction, right? So and the amount of gas that's incurred in the transaction gets debited from your account. We'll come to that later on in the video, right? Down here as well, just to there's an interesting so there's an example transaction where we've got let's say a contract. It adds two numbers together, and it consumes 3 gas, as we said with the add. And they've just done a sample calculation just to show you that the amount of whey at that gas price, at the default gas price, would be 1.5 times 10 to the 11, right? And then you can convert that back into ether if you want to see, and then you can convert that back into dollars using market rates. If you really want to see how much dollars and cents does it cost in today's market to add two numbers together, right? So that's how I'm trying to build a picture of how the kind of the bridge is built between all these different terms, right? So I'm just going to do some playing around here with balance transfers, just to sort of help you get a feel for how much, when I send a transaction, how much gas is getting consumed, and all that kind of stuff, right? So I'm just going to play around here. Hopefully you can follow along and it'll make sense, right? So the first thing I've done is I've created 2 new accounts on this node using the personal new account. I've assigned passphrases to them, and I have defined variables in the window A1 account 1 and A2 account 2 to represent the new accounts, right? So the account 6 and account 7 are the new accounts. Before there were 6, so account 5 was the last because it's indexed from 0. Hope that makes sense. So A1 and A2 are my new accounts, right? And they both have 0 balance, right? So if I do eth.get balance A1 is 0, and the same for A2. They're new accounts. If I do eth.get balance account 0, which is where we're doing the mining, if you remember, that's now a huge amount of ether. What I'm going to do now is I'm going to transfer a huge amount of ether from the miner to account 1, right? So what I need to do there is I need to create a transaction. So let's do that now. So before I start sending any transactions, remember every time I restart the console, the Geth console, I have to set this default account variable so that when I send the transaction, it knows which account to send the money from. Okay, so that's done. So I sent this transaction here, right? So if we do eth.pending transactions. So here's the simple command, right? So eth.send transaction, and I'm just creating a very simple message, which is the transaction body, which says give an enormous amount of the whey, right, to A1, right? And so let's see what's inside this actual transaction. So the transaction that's been created by the Geth client has populated default gas price. I haven't specified the gas price, so that's a default that's been set there. I can, and I'll show you in a separate transaction, I can put another value for gas price, and it's also populated the gas field, which is by default it's the maximum amount of gas that I'm prepared to spend in this transaction, right? So that's very important, and we'll get to this later on and explain it in more detail. But just to sort of give you an idea of what actually happens when we set up these transactions. So, and the value we've specified is 7 times 10 to the 22, right? So it was most of what the default account was actually holding, right? I've given away to account number 1, so as in to the new account that we created. Right, so let's see if it's arrived yet. So that account, so that transaction has been mined into a block, which means if we just do eth.get balance A1, we now see that A1 has 7 times 10 to the 22 whey in their account. So now A1 can actually start spending or start sending transactions themselves. So the reason why I set this up was because I want to show you the exact debits from the account from doing certain operations, and to do that I need to make sure that we're sending transactions from a different account than the miner who's running in the background. The reason is that obviously the miner's account balance is going up all the time anyway, because they get credit every time they mine a new block. And so with that going up in the background, it's going to be difficult for us to check and really validate exactly how much whey has been deducted for doing various things, right? So what I'm going to do now is I'm going to set the default account to A1. So now what I'm going to do is I'm going to send a transaction from A1 to A2. So I've made the default account A1. So now when I send a transaction, it's going to be signed by A1's user. And I'm going to say, okay, so A1 was the first new account, A2 was the second new account we created, and I'm going to say, A1 has just come into all this this huge windfall, and they're feeling generous, so they're going to give, let's say, almost half of it away to A2, right? So we send the transaction. So now we have another transaction. Okay. Let's hope we can catch it. Okay, so this transaction got mined straight away. Which is fine, but let's just have a look at it anyway, right? So we can do eth.get transaction, and then let's just have a look at what was inside this transaction, right? So the transaction we had was basically here was the value, and the to address was our A2, so our second new account. And again, the same values were used for gas because they were by default, and the same default gas price was used. If we do another one, okay, and we can send another value here. And what I want to point out is that everything inside the curly brackets down here, you can actually override the parameters within the transaction. So if I do value, and then if I slot in here after 2, I just do comma gas, and then let's say 8,000. So I'm saying I'm only prepared to use 8,000 gas for this. I can do it, and let's transfer this time. Let's just transfer again from account A1 to account A2. We only have 4 times 10 to the 22 left. So I'm going to send another 1 times 10 to the 22, right? This value here. Intrinsic gas is too low. So this is interesting. So we've actually said that. So the client has said we haven't specified enough gas for this transaction. So the previous transaction by default specified a gas of 90,000. We're going to specify 80,000. And if we have a look at the pending transactions, we can see that in this one, we've overridden the default value, right? And we've also got another one that we just sent there. So the point is, you can specify if you want. You can specify what the maximum amount of gas as a initiator of the contract. You're basically saying, do not use any more than this amount of gas on this transaction. If you do, then basically abort, and we'll go into what actually happens there later on, right? Effectively, what happens is that your execution is not going to complete. So our pending transactions have completed. So now if we do eth.getBalance and we do A2, we've transferred 5 times 10 to the 22 ether, right? Because we sent 5 different transactions from A1, and if we do A1.getBalance, so here's the interesting thing. So we're going to investigate this more in a second, but now, so originally there were 7 times 10 to 22 transferred from our mining account. 5 of them are now with our balance A2, and 1.999, effectively 2 times 10 to 22 ether are with A1, right, remaining. So A1 has about a third of what they received remaining, and then the rest they've already given to A2, right? So what I've done here is I've just created a variable called A1 balance before sending to A2 again, right? So we're going to send even more ether or more whey to A2. But I've kept a record of exactly how much that is, so we can track how much the balance has gone by when we send, right? So I'm going to do again. I'm going to send another transaction. So I'm going to send another 1 times 10 to 22 way. Let's just keep it as a default gas limit, like this. So I've sent another 1 times 10 to 22 way to A2. Here's the pending transaction. So we're going back to the default gas limit and the default gas price. Here's the amount, and here's the address of A2. Now, let's wait until the balance has. Let's wait till the transaction's gone through. It's gone through now. So now if we do, so A2 dot ETH dot get balance A2 and ETH dot balance. So now A2 has received that money or that ether, if you like, and here's the balance of A1, right? So let's drill down exactly how much the balance for A1 has gone down because of that transaction, right? So if we do ETH dot get balance A1 and then subtract the variable that we created up here. So we can see it's -1 times 10 to 22, but this bit on the end is the actual, this is the amount that we were charged, okay, for actually sending that transaction. So if we do this, I just want to really sort of isolate plus 1 D22. Then this is the actual amount of way that it cost us to send that transaction, right? So we can start to see how much it costs to do certain things. So yeah. So I switched off the DSLR, ran out of batteries, but so what I'm doing here, I've rather clumsily, but I've isolated the amount of way that it cost account number 1 to send this huge amount of ether, just in terms of transaction fees, effectively, how much it cost for that transaction. And it was something around this. And that's a very big number. I'm not even going to try to interpret it. The interesting thing is, so that's the amount of way. Now, if we want to see how much gas that consumed, right, then we can look at the gas price that we've given in the transaction. So remember, we specified the default gas price of this value. Again, the numbers in Ethereum are pretty huge, but so this is the price that we said we would pay the miner per unit of gas, right, up to a maximum of 90,000 gas for including this transaction in the blockchain, for mining this transaction into a block. So if we take this number here, the gas price, if we divide, so if we, and I'm just taking you through, I did some of these steps before, so I'm just going to sort of take you through them. This line here, so we took that number, which was the amount by which the account was debited, excluding the actual transfer money. I'm talking about just debited for transaction fees. If we divide that by the gas price that was specified in the transaction, right, then that gives us 20,999 gas. Okay, that's the amount of gas that it took to actually process this transaction, right? 20,999.9, so effectively 21,000. Now, so let's just confirm that this really is, that this parameter is what it says it is. So what I've tried to do, what I've done further down here, I'll just highlight the line that I'm talking about each time, is if I send another transaction with gas and I specify, okay, gas is 30,000, right? So the default was 90,000. If I specify 30,000, then the transaction goes through perfectly fine, right? Right. So 30,000 is fine. Remember this number here. This was the amount of gas that it actually took, right? In the recent transaction, 20,999. So if we specify maximum 30, then it's perfectly fine. If we specify a maximum of 10,000 gas, as in we're saying to the the Ethereum miners, I'm not prepared to spend more than 10,000 gas, or I'm not willing for you to utilize more than 10,000 units of gas to the transaction. And before we were even able to send the transaction, we got a warning from our client saying, from our Geth client saying the intrinsic gas is too low, right? So the client knows in advance that to send a transaction, we need at least 20, around about this number, 20,000 or 21,000 gas, right? So we know that 10,000 is not going to be enough, and we can confirm this, right? So we can say, well, let's try 20,000, and again, it's not enough. Well, let's work down from 30,000, which we knew was okay. So 29,000 is okay, 27 is okay, 26 is okay, 25, 24, 24 is okay. Double check again, 20,000, yeah, it's still too low. 21,000, yep, it's still okay. So we're finding basically that the amount of gas that we have to specify as an upper limit has to be 21,000, right? And as long as it's 21,000, so that transaction is going through, right? So that's a really interesting, at least I think it's a very interesting little thing to delve into, to monitor the account balance of an account before and after sending a transaction, looking at the gas price, and then saying, well, this is the amount of gas that this transaction has used. So let's try sending the same transaction but specifying a maximum gas price that is less than that. And yeah, indeed, we get this message saying the intrinsic gas is too low, right? So we know that in order to send a simple transaction, we need to use at least 21,000 units of gas, and we specify the maximum gas price that we're prepared to pay, or sorry, we specify the gas price that we, not the maximum, but the gas price that we are allowing the miner to use per unit of gas. So let's say that the 21,000, let's say at the gas price of the default. So if we look at the default gas price from our previous transaction, when we don't specify, right? So the gas price was this, right? And the gas we specified was this. Now let's say we need to send some more money. The total weight the maximum total weight in this transaction is going to be the gas multiplied by the gas price, right? That's the maximum that we're prepared to spend in terms of whey or ether, is the product of these two. Let's say that, so we know, well, we don't have enough, we don't think we can afford to send another transaction at this price. We can't afford 21,000 units of gas. Now we know we can't go below this in terms of the units of gas we specify in the transaction. But what we can do is say, well, okay, in that case, I'm gonna halve the gas price. So ultimately, yes, the number of steps, the maximum number of steps that I'm asking the network to execute is the same, but I'm only bidding I'm going to bid a much smaller gas price. So let's if we just try and send one again. So we're going to do the same amount of gas, but we're going to specify gas price of, and instead of this amount, we're going to be really stingy, and we're going to reduce that by half, right? Now, so we've still got, so let's have a look at the pending transactions. So now we've got our, so we're still sending the same, from the same address to the same address. Nothing's changed, except now we've overridden the default gas price, right? To now, and but the gas is the same, right? Because we know if we specify a lower amount of gas than that, lower than 21,000, the network is not going to even go over the network, because our client knows that is not enough gas to send a transaction, right? That transaction's finally gone through, so it's perfectly fine. Because it's a private network, we've managed to very easily get that transaction mined into a block specifying a lower gas price. But I just want to sort of really make sure that everyone's clear on the difference between gas and gas price, and the fact that these are the two parameters that you, as a sender of a transaction, are allowed to send to the network, right? So let's I want to talk a little bit about gas limit now. So gas limit. What is gas limit? Gas limit is it's a block level parameter. So you'll see it not in the transactions, but in the blocks themselves. So I've just done eth.getBlock 0. So this is the Genesis block, right? The very first block in the chain of my local network. And we can see, so gas limit here. Gas limit is the total amount, the maximum total amount of gas allowed per block, right? So a block consists of many transactions that the miners are essentially, just like in Bitcoin, grouping together in a big bundle, hashing the whole lot, and finding, and then keep reiterating or iterating over and over and over that, and effectively doing so until they meet the difficulty target with the hash, right? So, but the gas limit is the total amount of gas across all of the transactions in the block, okay, which are allowed inside that block, right? So this is a block level parameter. Now, the one interesting thing about this is that if you see over time, so this gas limit is 134 da 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 da. In fact, we can just refer to it here. Gas limit is this. If we do eth.getBlock and then eth.block number, we can see that the gas limit has gone down. Gas limit does not have to stay the same. The gas limit can evolve over time, and it evolves by the miners themselves. So the mining node, and whatever code is running, whatever logic is running inside that mining node, is allowed to change the gas limit on the block, as in the total amount of the gas used in all the transactions. It is allowed to change that by a small factor, and that factor is 1 divided by 1024. Okay, so it's 1 over 1024 is the ratio by which they're allowed to increment or decrement the gas limit on each block. So it's really important to clarify one thing here, which is that the transactions themselves, when we send a transaction, okay, the sender of the transaction specifies the maximum gas they're prepared to spend for that transaction, and what the block gas limit does. So the gas limit on the block level, okay, that determines the maximum sum of the gas limits on the transactions. And that's really important, because the miner doesn't actually doesn't know at the time of mining the block exactly how much gas is going to be used. They just know the gas limit, so they know that the transactions that they've been handed, they all have a gas limit specified, and it's the sum of those added together that cannot exceed the block gas limit. When they actually mine those into a valid block, meaning the total gas limit of all the transactions, the sum of the gas, not the gas used, but the gas specified in the transactions, the sum of those must not exceed the block gas limit. Then once they've found the block successfully, they send that block around the network, and every node then has to validate that block, which means running the transactions. Now, all you know in advance is that none of those transactions will end up using more gas than their individual gas limit that was specified. But in actuality, they will often use less. So what happens then is that any unused gas will be refunded back to or let's put it this way: that the sender of the transaction will not be charged for the entire gas limit of the transaction. They'll be only charged for the actual amount of gas that ends up used in the execution of the transaction. And just to give you an example here, so I just tried to send another transaction exactly as we did before. So we're not doing it. The transaction itself is no more cumbersome or complicated or whatever. It's the same transaction. We're just trying to send this amount of ether with this gas price, but we've specified a gas value in the transaction, which at the transaction level is the gas limit. We've specified as a number that is just slightly higher than the gas limit of the current block, right, which is 4.7 million. We've specified a gas limit, a gas in our transaction, a gas upper limit, let's call it, gas upper limit in the transaction of just over 5 million, which is, so at this point, this transaction does not actually, the client knows that no node is ever going to mine this. It's not going to be able to mine this into a block because even though ultimately the execution of this transaction is only going to incur a very small amount of gas, we've specified a huge safety margin effectively in the limit here, but that's actually going to stop any miner from mining that into a block, right? So I hope that kind of hope that makes some sense. So that's what gas limit is, right? So gas limit is over here is in the block, right? It's a block level parameter, right? So I just want to sort of finish off maybe with a quick example of a contract that does something, and we can actually look at some more examples of let's say adding some numbers together and how much that's actually costing to execute. So we're going to go back to our browser, right? So I created a very simple little contract here. It's a little piece of code in my browser Solidity window. Please see my previous videos on the very basics of setting this up. It's very easy, very intuitive. So a new contract. It has one contract variable called contract total, and has a getter method so we can fetch that. But then it has another method called add to total n times, right? So then the idea is that we're going to specify an increment to add to our total, and we're going to specify a number of times to do it, right? So you can see the code here is very simple. And we're going to say that so we're going to increment the counter each time until we get to, let's say, 10 times. We're going to do it 10 times, and we're going to increment the contract total by the amount to add, right? So I'm going to investigate the implications of running this function in terms of cost, right? So first thing we have to do is to deploy. So what we're going to do is we're going to connect to our local node, right? And then then we're going to create. So we're going to basically create a new instance of this. So we're just waiting for this transaction to be mined. So just to reiterate what is happening, we're deploying a new contract to the blockchain right now. Okay, so once that contract is mined and it has an account on the blockchain, we can then call these methods, and which is going to cost us money, right? Which is the whole point. So let's wait for that transaction to be mined. While we do that, let's just have a quick look at the transaction that our browser Solidity has created for us. So we haven't specified explicitly a value for gas and gas price, but you can see by default, for deploying a new contract, the browser Solidity it knows that we need to use a lot more gas than just to send ether from one account to another. So it's actually supplied a default gas limit of 104,395, and then the gas price it specified was the same one that we used earlier. So that's just interesting to point out that the gas that you specify for creating a new contract is much more than just a transaction that is transferring ether from one person to another. So that transaction has now come back. So what I'm going to do is I'm going to just set up the variables so I can call the call the methods on this contract. So I'm going to do var. You've seen me do this 100 times before probably. I'm going to copy the ABI, the interface from the window, and then I'm going to do var address equals, and then I'm going to copy the address. Right. So remember the if we just check the balance. So one thing I want to show you, right? So let's do the eth.get balance of the default account. Sorry, trying to do too fast. Is this now, right? This is the balance of our default account. What I'm going to do is I'm going to show you, just demonstrate that calling these local functions, calling these read-only functions, like just returning the current value of the contract, which has no update to state, does not change the balance at all. It doesn't cost anything, right? So if we do, so we're going to do adder n times dot get total is 0, and let's have a look at the balance. It's exactly the same, right? So calling the constant functions which don't send any transactions to the blockchain costs no money whatsoever. You can call these read-only functions in a transaction, but there's no point, because all you're doing is asking every node on the blockchain to run a method that's not going to do anything. So it has no lasting effect. So it would be a complete waste of money. But let's just have a play around with calling the add to total n times, right? So let's do add to total n times, and let's add 34 to the total, and let's do that 3 times, right? So here's the transaction, and just while we're waiting, so notice the gas here has been specified as 90,000, right? So this is by default we've specified 90,000, right? The gas price is the same gas price that we've been using all the way through. That's the default gas price. We can change it, we can make it higher, we can make it lower, but worth pointing out that the default gas that we specified here, or that the client has specified for us, is 90,000. Let's have a look at let's find out how much gas has actually been used by this method call, right? So to do that, what we're going to have to do is to check the balance after this transaction is returned, right? So the transaction is returned. So now, if we do eth.get balance, and then we do so it's A1, right? So this is the new balance, right? So if we do and then if you remember up here, this was the old balance, right? So this minus this. This is the total number of way that it cost us to execute this transaction, right? So if we divide this by the gas price, right? And this is the units of gas that transaction. So let's just make a variable from that. But var gas from 3 additions, okay? Because we specified add total 3 times, right? So equals, so we're just going to keep an eye on this. So this is the amount of gas that was actually used when we specified, right? When we specified add to total 3 times. So let's call this number, let's call this method again, right? But instead let's do 30 times, right? Now let's see. Okay, so the gas again is 90,000, right? Now we're adding 30 times. So by the way, I just checked the total just to make sure that it did work. So this is the result of the first execution. So we added 34 plus 34 plus 34. So that's why the total is now 102, right? So that's good to know. So you can see that the second call we made, which was to add 34 to the total 30 times, that has not yet gone through yet, right? Has not yet gone through, so we should still see here under pending transactions. Okay, so it's finished now. So now if we do get total, oh, so that's a very interesting thing that's happened right there, right? Very interesting. The total hasn't changed. So you know, I wonder what's happened here. So the total has not changed. The transaction has run through and is being mined, right? If you remember what the transaction was, it was saying we are going to perform this addition operation 30 times. Okay, well let's try 3 times again, right? Let's try adding 34 to the total 3 times again, right? So that transaction has gone through now, and lo and behold, the total is now 204. So this has shown us a very interesting thing, right? And I hope this is clear. So the first time we called this call, we asked 34 to be added to the total 3 times, and that went through, and we specified a gas price of 90,000. The second time we did it, we passed a parameter saying, yeah, do the same, but this time do it 30 times, using the same gas, right? The same gas limit, upper limit in our transaction, and it didn't get executed. Okay, that's really interesting. So in actual fact, the transaction has not been executed, and none of the state was changed. So the state was effectively rolled back to what it was before that transaction happened, which is really interesting and really important point. So let's try and do this again, but let's try, and then let's make the gas limit higher. So let's make the gas limit 500,000, right? So we're using a much bigger gas limit this time, right? So by the way, when I put this parameter in curly braces at the end of the arguments, we're effectively saying anything inside there is the parameters of the underlying transaction. So it's basically, if you don't specify this at all, then all of the parameters in the transaction are going to be defaults, basically, right? So this is interesting. So so that's already gone through. So let's see what the total is now. Okay, so it looks like by specifying 500,000 gas as the upper limit, okay, I was able to actually successfully have 34 added to the total 30 times, right? But I wasn't able to do so until I specified a higher gas limit than the default. So let's have a look at this actual transaction. So now we know that by specifying 500,000 gas, that is enough gas to call this add function, right, in our browser up here. So this is effectively in the Ethereum EVM, the virtual machine, we're just calling this add function. We know that 500,000 gas is enough to call that particular method and get it executed 30 times, right? So let's see how much gas it actually used up, right? So let's just check the current balance. Okay, so if we do eth dot get balance a1, right? Let's just do var b1 equals this. Then we just do personal unlock account a1, and then we do. So we're going to call this method again. I'm going to call this. I'm going to ask it to add 34 to the total. Let's just spice it up a bit and use a different number. Doesn't make any difference, right? And I'm going to 30 times, right? So we have a transaction there. Let's just check the total while we're waiting. So it's still 10224. We're going to wait for this to go through, and then I'm actually going to calculate how much gas it's actually used to actually call this to add this to go around this loop, right? So now our thing has been updated successfully. Okay, so we've added 25 to the total 30 times, right? So pending transactions, you can see, is 0 or empty. So let's check the balance now, right? So the balance is this. So if we do the B2 equals this, if we do B1 minus B2 is this. This is the amount of whey that transaction cost. So again, if we divide that number of whey by the gas price, this is the amount of this is the amount of gas that transaction, the overall transaction took, right? Including the fee to send the transaction around the network, but also the fee to have that adding functionality running in that loop, right? So let's assign a variable to that. So this is the var gas for 30 times, right? Equals this, right? So now what I'm going to do, I'm going to unlock the account again. And I'm going to send it around the loop only 10 times this time. Right? So let's just wait for that to finish. That's finished now. So our total has been incremented again to 2224. Let's see what the balance is now, right? So if we go back up here and we do ETH, if we do var B3 equals ETH balance B1, so B3. So let's check the difference now. So let's make this window a bit bigger. Right, so B2 minus B3 is this, okay? So this is the amount of whey to run around that loop 10 times. So if we divide that by the gas price, this is the number of units of gas to run 10 times. So to go around the loop 10 times was 73,267 gas, and to go around 30 times was 175,786 times, right? So you can see part of the cost of doing this depends on the amount of operations you're doing, and that's not known by the compiler until you actually specify. So it's not known at contract compile time because the amount of processing can be determined by the parameters you specify at runtime, right? So that's really how sort of gas really works, and how balances are updated, etc., in response to operations, right? And you can see that a component of the transaction is just to send the transaction, right? And then so if you like, if we sort of go back to here and say, so if we were to plot on a graph, let's say the n times, right, which is the parameter that we were passing to our method, and we were to plot the cost, or let's call it gas actually, because cost implies money. So let's look at, so what you'd actually see is that there would be some kind of relationship like this, right? So this here would be the cost of specifying n equals 0, right? And there's a fixed cost, and that fixed cost is basically just the transaction fee, right? So if we go back to the terminal and do specify n equals 0, so add 25 0 times, okay? We can see, if you remember, when we were just sending ether from one account to another, we're doing nothing to do with contracts. Do you remember the gas was around about 21,000, right? Which is really interesting. So 21,000 is the amount of gas that it took for this transaction when we're actually not looping round at all, because we specified 0 as the number of times to loop round, right? But still we incurred 21,000 gas, right? So, and then the other values were 175,000, okay, and 73,000. So if we go back to the graph, so 10, 30 over here. Let's extend it a bit. Right. This was something like 170,000 K, right? And then 10 was something like 70 K, and then 0 was just the fixed cost for the transaction, which was around about 21K. So you can see how there are various components, right? This is basically the fixed transaction cost, right? So various components that make up the actual gas that you incur, and this one is known at runtime, right? So you have to specify at least 21K gas to send a transaction, which is what we saw earlier on in the video, right? And then if you want to call contract methods within as part of that transaction, then you're going to incur extra costs per execution and per operation you do, right? And you have to make sure that so we specified our gas limit for this transaction up here as 500K, right? And when we specified a lower gas limit, remember what happened was that our transaction made it into a block because we didn't know in advance whether it was a 50K gas limit is the default, I think, if I remember rightly. When we specified that, the transaction went through into the blockchain, right? Because the client knew, well, in order to send a transaction, the minimum is 21K gas, right? Then let the miner mine that into a block, which it did. It successfully mined it into a block. But then, when executing the required method call, it ran out of gas, because we know that 30 requires that 30 calls requires 170,000 gas. So it wasn't until we increased the gas limit way above here that we were safely able to assume that that we would get our 30 iterations of the adding done. Now, if we move over here and extrapolate further, right? You know where this is going. If we want to be able to, so we continue this line up here, right? And so if our 500, if we extrapolate that across up there, then there's a limit down here. And this looks like it might be something like, let's say 45. So if we try and call, let's say 50 iterations around that loop by supplying the 50 parameter, and still with the 500k gas, then again, the transaction will be executed, but it will not complete. It will run out of gas, and the state will roll back to what it was before, right? So that's. I hope that's been a useful kind of little introduction or foray into the sort of various concepts around gas price, ether, way, gas limit on the block level, and also gas limit on the transaction level. I know it's been a bit of a long video, but something I always kind of got a bit confused about when I was reading about Ethereum, and I think it always helps to play around yourself, see real examples. So yeah, hopefully that was useful, and yeah, I'll see you in the next video. Bye.